So let's talk about inequality. The first question that you might have is, what exactly is inequality? Inequality is a statement that tells the relationship between two or more quantities. Basically, it tells us the connection between two things or quantities. Now, there are four basic fundamental symbols that you need to be familiar with in inequality. And these symbols include the less than symbol. Did I need to write it on word? Well, since you can be listening, then you should know what it is. So this is called the less than symbol. This is the greater than symbol. And we have the less or equal, and we have the greater or equal. What you need to pay attention to mostly here is the first two inequalities symbol, which is the less than and the greater than. If you find it difficult in distinguishing, in differentiating between the two, then you can always use your hand to tell. Your left hand corresponds to the less than symbol, while your right hand corresponds to the greater than symbol. Now, to successfully solve problems involving inequality, we have about two rules that you actually need to work with, which is the first one says that don't collect like terms when you have an inequality expressions. So you can have it written down. So get your pen and your jot notes. Don't collect like terms. Instead, you add or subtract whatever you are trying to get rid of or whatever you are trying to change its position. So you add or subtract it from both sides of the expression, of the inequality expression. So that is the first rule you actually need to always work with while dealing with problems involving inequality. Okay? Don't collect like terms. Instead, add or subtract the constants you are willing to get rid of, understand? Or the expression you are willing to get rid of. So add or subtract, let me just say the constants, okay? Constants from both sides of the equation or expression, not an equation, okay? Because in inequality expressions, we don't have an equal sign, okay? From both sides. From both sides. Perfect. So that's the first rule. Now for the second one, it says that whenever you multiply or divide both sides of an inequality, you are expected to reverse the inequality symbol. I repeat that. Whenever you multiply or divide both sides of an inequality by a negative sign or a negative number, then you are expected to reverse the inequality sign. What does that mean? It means if before you multiply or divide both sides of the inequality by a negative sign, you are having a less than symbol, for instance. Then after doing that, after multiplying or dividing by a negative sign, you have to reverse the inequality and turn it to greater than. And this works in the vice versa. So let me write it in word for you. Number 2. Okay. So whenever you multiply or divide both sides of an inequality by a negative sign. This is A by negative sign, SIGN. Then you are expected to reverse the inequality sign. Inequality sign. Perfect. I have a video that basically explains the reason why you need to undergo this second rule whenever you divide or multiply both sides of inequality by negative sign. Okay, I explain everything you need to understand. Okay, about the rule. Perfect. You can check it out. I will leave the link, or you should just check out anywhere around the top of the video if it's pop up, or it should be in the description. Perfect. So this is basically what you need to know about inequality, the signs and the rules. Excellent. Now, we basically have different forms of inequality. We have linear inequality, quadratic inequality, double linear inequality. We have a rational inequality, and so on. But for the sake of this video tutorial, we will consider problems involving linear inequality. So let's begin. Example number 1. So consider the inequality 2x minus 3 that is less than x plus 7. If our goal is to find the possible values of x that satisfies this inequality, what would be our process? In fact, what would be the first step to do? Well, the first step is to find a way to have the variable at one side and the constant at one side. You understand? If it's an equation, then we would have correct like terms. But since it's something that is restricted in inequality, then we have to be careful. So basically, let's first of all add 3 to both sides. Now, let me give you a hint. Always make sure that the variable you are looking for, the variable you are willing to solve, the variable you are willing to find the corresponding values of it that satisfy the inequality, always make sure that you have it at the left hand side. Don't solve for it in the right hand side. Solve for it while it is at the left hand side. Please, I hope that part is clear. So we want to make sure that x terms is at the left hand side and the constant terms without x is at the right hand side. So first of all, let's get rid of the minus 3. And to do that, we can add 3 to both sides. Okay, so you can, if you want, you can have it in Word. But accepted, it shows you know what you are doing. But we don't do that. Okay, so let's add 3 to both sides. We have 2x minus 3 plus 3 less than x plus 7 plus 3. So thus, for the left hand side, these can get in the way of this. And then we have 2x less than, and then we have x plus 7 plus 3 is positive 10. Perfect. Now x is here, and our goal is to have x at the left hand side. Okay, perfect. So this one, sorry, we might need to leave that space. And for we to get it away from the right hand side, we need to subtract x from both sides because it's actually positive x, and we need its opposition. We need opposites to get rid of it. Okay, perfect. So now let's subtract x from both sides. So we have 2x minus x, so less than x minus x plus 10. Now you might be wondering, why did I bring it here? Well, if I have it as plus x, that's like plus 10 minus x, I can still rearrange. Okay? And then I have x minus x plus 10. So just be careful. Okay? So far, you are not crossing a certain boundary. So changing the position of your terms will not alter the sign associated with that term. Do you get that? So far, you are not crossing any boundary for an equal sign or an inequality sign. Then, whatever sign that is associated with a certain term is like x, number, and so on. Then, if you change its position, that sign will still be with it. It's not going to change. Perfect. So, I change x, bring it here. It's still minus. It doesn't change. Okay, but get rid of this one. Then we have 2x minus x is simply x. Then we have x to be less than 10. those. We have the values of x. So those are the values of x that satisfy the inequality. That's it. Simple as that. Example number 2. Well, you don't need to get rid of it. You can just have it at the right inside at this other side. So we have 1/3 of x minus 2 to be less or equal to 2 over 5x. 2 over 5x plus 1/4. So what do we do? So our first step is basically we need to get rid of this 2 or this minus 2 away from there. Don't forget, x times will be at the left hand side. So we have 1/3 of x minus 2 plus 2. So we basically need to add 2 to both sides, less or equal to 2 over 5x plus 1/4 plus 2. Excellent. These can get rid of themselves, and then we have 1/3 of x to get less or equal to 2 over 5x plus. So now we need to add these two fractions. So this is a whole number, but it's a fraction. When going to divide by 1, it's a fraction. So let's see that's 2 over 1. If the LCM is considered as 4, 4 in 4 is 1 times 1 is 1 plus 1 in 4, this is 1 in 4 is 4. We multiply with the numerator 2 becomes 8. 4 times 2 is perfect. Thus we have 1/3 of x to be less or equal to 2 over 5x plus 1 plus 8 is 9. So we have 9/4. Excellent. So now these has to make this one. For that to be possible, we need to subtract 2 over 5x from both sides. Then we have 1 over 3x minus 2 over 5x minus 2 over 5x. That's less or equal to 2 over 5x plus 9 over 4x minus 2 over 5x. Perfect. So just as the way we did it earlier in the first example, we need to attach this and this together where the sign will not change. What will be the LCM of 3 and 5? That's 15. So we have 3 in 15 is 5. 5 times 1x is simply 5x. The minus 5 in 15 is 3. 3 times 2x is 6x. And that's less or equal to. So now, this will obviously cancel this by the time you bring them closer. Okay? So remember, the sign will not change. So 5 is not causing element, and we have it to be 9 or 4. Perfect. So 5 minus 6x. Or this can go at this point. Sorry, we don't need it anymore. So now 5 minus 6x. 5x minus 6x to see makes sense. It's just minus x divided by 15. That's less or equal to 9/4. Perfect. So what do we do next? Don't cross multiply. Okay? Don't do that. You don't want to do that. We don't do that in inequality. So instead, we multiply. So let's multiply both sides with 15. Then we can have minus x over 15 times 15. So that's less or equal to 9/4 times 15. So you can also add that to part of your rules of inequality. Don't cross multiply. You instead multiply both sides or divide both sides with whatever you know that will get rid of what you are trying to get rid of. So now this cancels out. So left over is minus x, less or equal. 9 times 15 is 135. So we have it divided by 4. Now at this point, we can just multiply both sides of the inequality by a negative sign. Thus we have minus x multiplied by minus 1 to be less or equal to 135 over 4 multiplied by minus 1. Now whenever you multiply both sides of the inequality by a minus sign, remember you have to reverse the inequality sign. So these shouldn't be less than anymore, but now greater than or equal. And finally we have x to be greater than or equal to minus 135 over 4. So that's our final answer to the problem. So this is how you can easily solve problems in inequality, and The stated goals are the goals you actually need to be familiar with. Now, this problem might be solved by some other educators in another way. Regardless, the goal is just for you to know how to do it yourself personally. So if you find this method helpful and the video personally, and if you find it useful, kindly leave a like and subscribe to the video. Thank you for watching. See you in the next video. Bye for now.